I am just going to show a quick video on using synthetic division for the polynomials. And I'm going to make up a problem. Let's see, let's take 2x to the third minus 3x plus 7. And let's divide it by x plus 2. All right, so we're going to set this synthetic division up. And remember that synthetic division can only be done when you have just a linear expression here, like x plus a number or x minus a number. That's the only time that it'll work. All right, so we're going to put up here in this little spot, we're going to put the zero form of this, which is -2. So it's always the opposite sign. And then we're going to list the coefficients of the dividend. So we're going to start here. The biggest is the degree, 2x cubed. So we're going to put 2. But if you notice, there's no squared term. We don't have 0x squared. So we'll have to put in a placeholder for that. -3 and 7. So if you look, what we have too is we have the -3 represented by this here. So if you see subtraction here, you should see a negative. So we will drop down the first number. That's always our first step, 2. And then we multiply up. 2 times -2, -4. Then we add down, -4. We multiply up. We're going to get a +8. Add, we'll get a 5. 5 times -2, -10. And if we add this, we get -3. And our last number here is always our remainder. So a couple of things we can find out from here is that -3 is the remainder. So we know that x plus 2 is not a factor. And we also know if we evaluated this expression at -2, as a result, we'd get -3. So if -2 is an input here for x, an output would be -3. So we could actually think of a coordinate point being -2, -3 if we wanted to plot it. So now writing the final answer, we are always down a degree because we had a cubic, something to the third, we divided it by a linear, so we're going to end up with an x squared being the degree of our quotient. And I'm just going to take all of these numbers here, and those are going to be the coefficients to my quotient. And we'll add in -3 over x plus 2, and here's our final answer for the division.